Hi everyone, in this video I just want to go over some of the basic properties of logs and a few examples for how we use them. So the first property is that if we look at log of 1, no matter what the base is, the answer is always 0. So in particular, for the natural log, ln of 1 equals 0. If we look at log of a, where the base is a, we get 1. And on the natural log side of things, since ln is the same as log base e, if we take ln of e, we get 1. The next two properties are some of the most important ones. They're called the inverse properties of logs. The first one says that if we do log base a of a to the x, we get x. So this looks a lot like the previous property, except instead of getting 1, because a was to the power of x, we got x. The previous property is actually a special case, because log base a of a to the 1 is the same as log base a of a. So we're just left with that exponent. On the ln side of things, this looks like ln of e to the x equals x, just because this is log base e of e to the x. The other way to phrase the inverse property is that if you take a and you raise it to the log with base a of x, we're just left with x. If you take e and raise it to the log base e, or the ln of x, we're just left with x. And these really truly are inverse properties if you think about it, because if we write f of g equals ln of, or f of x equals ln of x, for example, and g of x equals e to the x, then ln of e to the x is the same as f of g of x, and we're saying that equals x. So it says that ln and e are inverses. E to the ln of x is like doing g of f of x, and we get x. So again, they're inverse functions because when I compose them, I get x. There's another video that elaborates on this idea. So let's see some examples for how we might use these properties. Oh, and actually, sorry, there's just one more. If we take log base a of x, and that equals log base a of y, so we have the same base here and here, then x has to equal y. So if we have ln of x equals ln of y, then x equals y. These are called the one-to-one properties. So now let's see some examples for how we use these. So if I do log of 1 with base 4, if I apply the first property, that tells me that I should get 0. And if you think back to evaluating, what this is really asking is 4 to the what equals 1, and 4 to the 0 equals 1. So log base 4 of 1 equals 0. That's where that property comes from. Now if I have log of square root of 7, base square root of 7, this is really messy, but if I use this property, log base a of a, the base is the same thing I'm evaluating the log of, I should just get 1. Because what I'm really asking is square root of 7 to the what equals square root of 7. So that question mark is 1. E to the ln of 5 is our next example, but e and ln are inverse functions. So when I compose them, as I'm doing here, I should just get 5. So here I'm using property 3. Here I was using property 2. Here I was using property 1. Now, finally, if I have ln of x squared minus 6 equals ln of 10, I'll have two ln's that are equal to each other. They have the same base. They both have base e. So by property 4, that means the thing inside of the ln those things have to be equal to each other by the one-to-one property. So this tells me x squared minus 6 is equal to 10. And that tells me that x squared is equal to 16. So x is equal to plus or minus 4. So now let's just take a moment to see why these things are true. ln of 1 equals 0. Why should that be? Well, if I'm trying to evaluate ln of 1, then, like I said before, what I'm asking is e to the what equals 1. If I want to take a number and raise it to a power and get 1, that power has to be 0. So that's why ln of 1 equals 0. For our second property, why does ln of e equal 1? If I try to evaluate ln of e, what I'm asking is e to the what equals e. So that question mark has to be 1. If you raise something to a power and get that thing back, well, the power you raised it to must have been 1. So that's why ln of e equals 1. Now, if I look at this property, we sort of already explained this, but let's go through it more carefully. So if I let f of x be the function log base a of x, then this is saying that a to the f of x equals x. And if I take g of x, and that's going to be the function a to the x, then by looking at the composition of these functions, f of g of x, well, I have log base a, instead of x, I put g of x, of a to the x. These functions are inverses of each other, so I just get x back. And if I compose in the other order, if I do g of f of x, then I'm doing a to the f of x, which is log base a of x. Since these functions are inverses of each other, that will just give me x. And how do we know they're inverses? It just comes from this definition of logs. And check on that video why that will explain this relationship in a little bit more detail.